This training program deals with analysis of water flood performance using Microsoft Excel. To just give a brief introduction of myself, I'm a petroleum engineer with 4 decades of experience in petroleum engineering. I have worked for a number of companies in India, like Oil India Limited, BG Group, and I've worked internationally in shell exploration and production, and also in petroleum development Oman. While in shell and petroleum development Oman, I was a technical authority of reservoir engineering. I have a master's degree in petroleum engineering. I have taught in a number of universities as a guest lecturer. I have delivered multiple training courses in petroleum development Oman and shell, and I have a number of technical publications in international journals. Many of them relate to water flood. To begin with, what is water flooding? To define simply, water flooding is the process of injecting water into the reservoir to increase oil recovery. So any process by which we inject water in the reservoir and the aim is to increase oil recovery, we call that water flooding. So usually water is usually injected into dedicated wells. We call them injectors. And this water that is injected physically displaces oil residing in the pore space towards the dedicated wells, which are the producers. This diagram gives an idea of the whole process. This is the injector by means of which we are injecting water. This is displacing the oil which resides in the pore spaces, and it is produced to the producers. So whole aim is to recover more oil, and that maximizes the value of the asset because we are increasing the recovery. In earlier days, there was a distinction made between water flooding and water injection for pressure maintenance. Water flooding was referred to those processes where water is injected into the oil zone to physically displace oil towards the wellbore, and water injection for pressure maintenance was used primarily for the purpose of maintaining pressure, and water was injected in the water zone. But in current petroleum engineering literature, the distinction between the two is not made. If we inject water and the aim is to really maximize my oil production, everything comes under water flood. Because even if you inject water in the water zone and call it for pressure maintenance, there's a significant component of sweep in the process. Coming to why really water flood is the most really deployed recovery mechanism. Water flood, by a large degree, is the most dominant deployed recovery mechanism. More than 50% of the oil production that we get today is due to water flood. The reasons are many, because if you really produce only under primary depletion, you are left with a lot of oil and gas in the reservoir. It can vary from 60% to 80%. There are a number of reasons for that. Maybe the natural energy or the drive mechanism is not efficient, is not adequate. Your displacement mechanism is inefficient. There can be permeability contrast in the reservoir, because of which your sweep efficiency is poor. There can be fractures, or maybe you're not using appropriate number of wells or well locations to really recover the oil. This is one of the reasons, since so much of oil is left behind. And next, the water availability is very good. You will always get the source of water for injecting. You might have to treat it. Water is available in sea, water is available in ponds. We have produced water. So generally water availability for water injection is good. Now this water flooding that we know today was born in Bradford Field in Pennsylvania more than 100 years ago. So water flooding is not a new technology, really. It's a very common practice. And most of the things related to water flood developed between 1940 to 1970 in the US. So it's a very, very mature technology. Now, why is analysis of water flood important? These statistics presented in this slide will make it clear. About 50% of the proved oil reserves in the world can be attributed to water flood. So whatever is the proved oil reserves we have got, 50% of that roughly can be attributed to water flood. Even 50% of the production that we get today is due to water flood. Now, total proved oil reserves in the world, the latest estimate is about 1.75 trillion barrels. And 50% of that, that is 875 billion barrels, is due to water flood. Now, this water flooded oil, if we can just increase the recovery factor, okay, marginally, or we increase water flood recovery just by 10%, let us say my recovery factor goes up from 30%, typical number for water flood, to 33%, just by optimization of water flood. That means the additional reserves that I am accruing because of that is 10% of 875 billion barrels, which is equal to 87.5 billion barrels. Now, current oil consumption in the world is about 35 billion barrels. So the amount of oil that we will get extra can really suffice for 2.5 years of total consumption. And more importantly, this additional volume can be produced at a very negligible cost as compared to the cost of finding new oil, which anyway has become very difficult. The possibility of finding large reservoirs has dwindled drastically. And if we talk about additional recovery by use of enhanced oil recovery techniques, they are very, very costly. Having understood the importance of water flood, this particular training will focus on analyzing real field data. None of them are really synthetic data, to find out how is the water flood performing. Is it good or it is not good? How do you know it is good or not good? Suppose it is not performing. Why it is not performing? The whole reservoir not performing, or the problem is concentrated only a few sectors of the reservoir, or there can be a case where only a few wells, the good producers, you think they should produce well, they are not performing. In this training program, we'll use simple Excel sheet for diagnosis of water flood problems. Let me tell you, all the examples given will be real field data and not synthetically generated ones. We can use really Microsoft Excel for really looking at various aspects of water flood. And this short training program is a precursor to a longer duration training program, which will follow depending on the interest of the participants.